Most people assume that if a device is small, it can only do small things. So when someone claims a compact battery, power station, or inverter can run large appliances, the reaction is immediate skepticism. It sounds like marketing exaggeration or a misunderstanding of basic physics. That doubt is reasonable, because in everyday life, size feels like a proxy for power. Bigger appliances need more energy. Smaller devices feel limited by definition, but this assumption hides how energy actually works. At first glance, the question seems simple. Can a small device power a refrigerator, a microwave, or a washing machine? People usually answer it by looking at appearances. The device looks portable. The appliance looks heavy-duty. The mismatch feels obvious, then they start checking specs, wattage ratings, surge power, capacity numbers. Suddenly, the question gets confusing. Some small devices claim surprisingly high output. Others fail instantly under load. This is where frustration sets in, because the numbers look impressive, but real-world stories are inconsistent. One person runs a fridge without issues. Another trips the system immediately. Same appliance. Similar device. Different outcome. So people conclude the technology is unreliable, but that conclusion skips the structure underneath. The real complexity isn't about size. It's about how energy is delivered over time. Large appliances don't always need large power continuously. They need it in bursts. Startup surges, heating cycles, compression phases. After that, demand often drops sharply. Small devices can handle this sometimes if they're designed for it. At first, explanation stays shallow. People say the device is underpowered, or overrated, or that manufacturers exaggerate capabilities. Those explanations feel safe, but they're incomplete. Then comes the turning point. The real issue isn't whether small devices can power large appliances. It's whether they can handle the specific pattern of power that appliance demands. Energy isn't just about watts. It's about timing, surge tolerance, and duration. A compact power station might run a refrigerator for hours but fail instantly with a kettle. Not because the fridge is smaller, but because its load is smoother once running. This is why people get surprised. They expect a simple yes or no answer. But energy doesn't work that way. Small devices don't replace large systems. They exploit gaps, moments where high power isn't constant, only occasional. Understanding this reframes everything. Instead of asking, is this device powerful enough? The better question becomes, what kind of power does this appliance actually use? Once people see that distinction, disappointment drops. Expectations become realistic. Use cases become clearer. This also explains why many setups work partially and fail when pushed further. One appliance works. Add another, and everything collapses. Not because the device lied, but because overlapping demand breaks the pattern it was designed to handle. People who are satisfied usually learn this through experience. They stop testing limits for ego and start designing around behavior. Short runtimes. Staggered use. Specific priorities. The device stops being a miracle solution and becomes a tool. That's when small devices make sense, not as replacements for the grid, but as bridges filling specific gaps where large systems aren't available, practical, or necessary. When this distinction isn't explained, people feel misled. When it is, the technology suddenly feels honest. Small devices can power large appliances, just not in the way most people imagine. If you want a structured breakdown that explains how to match devices to appliances realistically without hype or guesswork, there's a practical guide linked in the description. If this kind of grounded explanation helps you think more clearly about energy claims you see online, consider subscribing. More long-form breakdowns like this are coming.